Okay, so I'm recording. Okay, so now we are going to learn about properties of wave 7.4 actually. Yeah, we have done 7.1, 7.2 and 7.3. All those subtopics, they are referred to simple harmonic motion. Okay, actually simple harmonic motion is oscillation of just one particle. Yeah, for example, let's look back what we have learned. Yeah, I hope that you already watched all my videos before this about simple harmonic motion. Yeah, 7.1 to 7.3. Okay, if you look at what we have learned before, we are just learning about oscillation of the mass on a spring. Yeah, just one, we can consider this mass as one particle. Oscillation of one particle, oscillation of one mass, like a pendulum also. Oscillation of just one pendulum, oscillation of just one pendulum, like this ball, oscillation of just one ball, one only, isn't it? Oscillation of a block, one block, movement of a child on a swing, just one child, motion of a pendulum, just one pendulum, motion of piston in a car engine, just one piston, vibration of atom in solid. Okay, we are looking at just one atom. So everything is just one particle. You see that? That is for simple harmonic motion. Okay, oscillation of just one particle. And we have learned about the formula also. Like for example, the displacement formula. We want to find, let's say, the displacement of the mass on a spring. Okay, this one is displacement of just the block of mass. Yeah, just one block. Yeah, over time. So different time, different displacement of the block. Correct or not? Just one block. Okay. Even this velocity, also velocity of just one block. Velocity of just one block over the time. And we also learn about what? We also learn about acceleration. Acceleration of just one block. Yeah, also acceleration of this block. Just one block. Okay? Over time. Now, what if I want to talk about displacement? Let's say displacement of, let's say there are a roll of atoms oscillate at the same time. Yeah, oscillate at the same time. And then I want to describe the displacement of each of the atom. Let's say, for example, I want to talk about. Do you see that? This like this. You see, this is what do you see? This is not just one mass, one block, or one pendulum. Not just one block or one pendulum. This is many particles, isn't it? Do you see this? Where do you see this kind of wave? Where do you see? Class, where do you see?
The ocean.
The ocean. That's very good. The ocean. The ocean. So ocean surface, the water surface has many water particles. All of them oscillate together, right? Not? So can you also calculate? Yeah, last time we can calculate the displacement of just one particle. Yeah, where is it? We can calculate the displacement of just one block. Yeah, just one block. We can calculate the displacement of the block at any time. What if I have a roll of water particle? A row of water particle. Oh, so many water particle here. Can I calculate the displacement of each of the particle also? At different time? At different distance also, you see? Some particle, this particle is at the disturbance. Yeah, this block is like the disturbance of, this is the block that makes the water start to ripple. Yeah, disturb the water and then start to have ripples going out from the point of disturbance. So the first particle is at the block. What if particles like the red one over here? You see, this is some distance away from the first particle, right? How about this another red particle, another distance away? And then how about this red, the third red particle? Even further, kan? Different distance, right? And then how about the fourth particle? Even further. And then the last particle? The last red particle, even further. So all of these particle, not just the red particle, all the other black particle are at different distance. Different distance. I should write something over here. I should write over here something, you know. Sorry. So some of them are, you know, like this particle to here. They have x, let's say distance 1, and then at the next particle that at you know, distance 2, and then how about this particle? They're at distance 3. Actually, not just a red particle, we can also talk about the black particle. I just take the red particle as example. All the black particle are at different distance from the first point, isn't it? And also, how to, let's say now my question is, how do you calculate the, let's say this is the equilibrium position, correct or not? This is the equilibrium position because the center line is the equilibrium. So can you calculate, let's say, the displacement? The displacement of, let's say this is y4. Displacement of the you know, I cannot stop this animation. Let's say the red particle is at some point of time, the red particle is over here. At some point of time, maybe this one at time equal to 4 seconds, let's say. So can you calculate the what is this distance? How far is this particle away from the first particle? How far away? Maybe we can put this as x4. X4. Am I right? Okay, x4. This x4 away. Okay, so at this time, what is the displacement of this particle? Let's say this particle, if I able to stop this animation, I stop at this time. Okay, what is the can you calculate y4? The displacement of that particle at this time, at this distance away from the origin. What is the first particle called? It's called origin lah. I can say it is x equal to 0. We put it as x equal to 0. Is called is called origin. So can you calculate y4, the displacement of that particle x4 away from the origin at this time? Can you? Is there a, so my question is there an equation? An equation to calculate, let's say, let's say this point or that point or that point, or you know, displacement. Can you calculate their y? Can you calculate, you know, their displacement? Can you calculate their displacement? Just now, this is y. Maybe put this as y1. This is you know, this is y2, and this is y3. This is y. We have y4, and what about this y5? Can you calculate all this displacement? Can you calculate all this displacement? Is then somebody please switch off your microphone? You accidentally open your microphone. Okay, wrongly, displacement y1. Can you, my question is there an equation to calculate the displacement of all these particles at different time, at different distance away from origin? Is there an equation? That is our mission today. To find out what is this equation to represent all particles at different distance at different time. As you can see, at different time, they all have different displacement, right? You see, let's say at 4 seconds, the particle is at below. But at 5 seconds, the particle is over here. Maybe I can write. Maybe at at let's say at this time. So at maybe at 6 seconds, the particle is over there. So the displacement become different already. Here, so the displacement become different already. Correct or not? Because why? Because once the things start to have ripples, when the water waves start to generate, so all the water particle will also oscillate. So at different time, they will have different displacement. Do you see that? At 4 seconds, maybe you see the particle here. After some time, it over here. You see that? After some time, it below. After some time, it above. Okay. Can you understand and can we understand what I'm talking about, class? Boleh ya? You boleh tangkap gambaran saya kan? Dan ni nampak di sini, apa yang nampak di sini? Dia cakap apa ini? Wavelength. Ini panjang gelombang lah kan? If you look on the water surface, you look at the ripple of water kan? What you can see is we can say this is a crest. What you see on the water is called crest. Kita panggil apa? Crest, puncak. Pernah belajar tak puncak di SPM? Pernah. Kalau di bawah itu dipanggil trough. Dipanggil trough. Itu dipanggil lurah. Betulkah saya punya terms? Ada puncak, ada lurah kan. So apa yang gelombang yang you nampak atas air, this is we can say this is water wave lah. Water wave. So this is all these are water medium, water medium. So water wave needs water, yeah. It needs water to transmit the wave. Yeah, it needs a medium. That's why it is called mechanical wave. Yeah, a water wave is called mechanical wave. You know what is called mechanical wave? Because it needs a medium. It needs a medium. Yeah, mechanical wave needs what is this? I always choose the wrong one. Mechanical wave needs medium to transfer the energy. Needs medium to transfer energy. Like water, it needs water medium. Yeah, all these are water particle. Yeah, all of them are oscillating. There are another type of wave called electromagnetic wave. Let me go out and see. Keep it. Did I hear the mechanical wave? You see that? So now I introduce mechanical wave. Yeah, is this defined as disturbance that travel through particles of medium to transfer the energy. Okay. I think it's also right for me to explain something here. There are different type of wave. Okay, I teach you more than the syllabus. Yeah, I think I should. Okay, types of wave. We have two different type of wave. Okay, I think you learned this in SPM. Okay, first is the mechanical wave. Mechanical wave, and then the next is electromagnetic wave. See how fantastic is my writing? Yeah. So, what is the difference between mechanical wave and electromagnetic wave? Mechanical wave needs medium. It needs medium. No medium cannot transfer the energy. Yeah. Electromagnetic wave, no need medium to transfer energy. You no need medium. No need medium to transfer energy. You see, what kind of mechanical wave we have? We have, let's say we have water wave. Right? So water wave, it needs water. No water cannot transfer the energy, right? And then how about another like sound wave? Sound wave needs what? Needs what medium?
Air.
Air. Air. This water wave needs water. So it needs a medium. Yeah? All these are medium. Let's say if no sound, if no air, like in the space, when you talk to each other, can you listen to the sound?
No.
No. In the energy of sound cannot transfer through vacuum. Maybe you can do an experiment in a vacuum space. You try to talk and then your partner cannot listen to the voice. Because why? Because no air particle to transmit the sound energy. Do you realize that when you talking, actually the air particle also oscillate? You actually can demonstrate this, just take a membrane or surface and then you start to talk to the membrane, or you make a voice or sound, you can see, and then you put some powder on the membrane, you can see the membrane start to vibrate. And then you can see clearly the powder also jumping up and down. You know why? Because it's the air particle that oscillate when your sound energy come out from your mouth. And then the air particle which is oscillating also oscillate the membrane. You can actually make this experiment. Yeah. So mechanical wave like sound wave needs air particle. Okay. What is the wave that no need medium, like electromagnetic wave? Can you tell me? But you still feel it? What wave no need medium?
Radio wave.
Radio wave. That's right, radio wave. Radio wave. You know, the radio wave can transmit through the to the space, and then the wave is received by the satellite. You know why the satellite can receive the wave? Because radio wave doesn't need what? Doesn't need any air particle. Even the light. All these are electromagnetic wave, light wave, radio wave, microwave. There are so many electromagnetic wave like X-ray, and what else? Infrared, ultraviolet, ultraviolet. All these no need medium. Okay, we can feel the heat. You can feel the heat of the light from the sunlight. The sunlight reach our Earth through the space. No air particle, no medium at all to transmit the light. Why? Because it uses magnetic field and electric field to transmit the energy. Actually, yeah, it uses electric field and magnetic field to transmit the energy. So it doesn't need medium. So this is a special of electromagnetic wave. Okay, radio wave can travel through the satellite without any medium. Okay, so no need medium. So that's the difference between mechanical wave and electromagnetic wave. So now, but in our chapter, we don't learn about electromagnetic wave. We are going to learn only mechanical wave. So mechanical wave, so we only learn, because why? Why we only learn mechanical wave? Because we are going to need medium. Yeah, we need medium. Yeah, we need medium because we are now talking about many particles. We are talking about the medium, the oscillation of the medium particles, many particles. And we want to find the equation of the displacements of the medium's particle. You understand? That's why our syllabus only learn about mechanical wave. We don't learn about electromagnetic wave. You're going to learn electromagnetic wave later chapter. I think in semester 2. Yeah, not now. Yeah. So it's mechanical wave. So we are going to deal with a lot of medium particle. So we are dealing with only mechanical wave. Okay, understand? Okay. So you see, so we need mediums, okay, to transfer the energy. So based on the transfer of energy, we have progressive wave and standing wave. Okay, so Progressive wave can transfer the energy, but standing wave cannot transfer the energy. Later we will learn about standing wave. Yeah, how is the wave become standing and stationary? Yeah, progressive wave is also called traveling wave. So when the wave need to travel, then only can transfer energy. If the wave doesn't travel, like standing or stationary, it cannot transfer energy. Yeah. So maybe I should write something over here. Okay. I can write something. So this one can transfer energy. This one cannot transfer energy because it's standing there. This one progressive. Progressive can transfer energy. This one cannot transfer energy. So maybe you can look at also. Finally, we're going to learn about standing wave also. See that? Compare between progressive and standing wave. See these terms here? I straight away actually I teach the thing first. So you see, progressive wave transmit energy. This one not transmitted. Energy not transmitted, but stand in the place. Does not transmit energy. See that? Okay, we will come to here later on, not now, yeah? Okay, go back to our slide. Cannot transfer energy. So progressive wave is defined as wave that is propagated continuously outward from a source of disturbance. So just now, my example here, this is what we call disturbance lah. Yeah, this is what we call, you know. Wait a second. So this is what we call disturbance. Okay, and then the energy is transmit out. Energy transmitted outward. Energy transmitted outward. How the energy is transmitted outward? Through oscillation of many particles. Through oscillation of many particles. Okay. Through oscillation of many medium particles. Can you see my word there? Can you see my word? Class, can you see my word?
Okay. Yes, sir.
Through oscillation of many medium particles. Through oscillation. So energy is transmitted outward. So what is the direction? Direction of energy transmission? Direction of energy transmission is horizontal. Energy transmission is horizontal. But for transverse wave, the oscillation is vertical. Can you see that? Can you see how is it? There's so many. Oh, the oscillation is if you look carefully, the oscillation is vertical. See that? The oscillation is vertical, kan? But the energy transmission is horizontal. The energy is transmitted from left to right. Energy is transmitted from left to right. At first, it is only the disturbance oscillation. Only the disturbance oscillate. But then it disturbs all the neighboring particles. And all the neighboring particles also start to oscillate up and down, oscillate vertically. As the neighboring particles oscillate vertically, then the energy is transmitted outward horizontally, from left to right, through oscillation of many medium particles. That's how energy transmission happens. Okay? Okay, good. So all will be very good, yeah? But sometimes, the energy is not just, sometimes, what you can see over here, this particular oscillation, you have, what do you call, hold on a second, let me see. So, there are two types of wave, okay? One is called transverse wave, and the other one is called longitudinal wave. Okay, so now I'm trying to tell you the oscillation of particles. Okay, oscillation of particles. So as you can see, the first one is longitudinal wave. Yeah, we are talking about progressive wave right now. Yeah, progressive wave right now. Progressive wave also have two type. Yeah, progressive wave also have two type. Okay, one is called transverse. One is called longitudinal wave. So the first one, as you can see, is longitudinal wave. The second one is called transverse wave. What's the difference? What's the difference? You see, this energy transmission is always what? Energy is still horizontal, kan? For both wave, energy is still horizontal. No matter it's longitudinal or transverse, energy is still horizontal from left to right. However, you compare their oscillation of medium. This spring, this is the spring, is a longitudinal wave. It is the oscillation is parallel to the direction of energy transmission. So the oscillation of the medium is horizontal also. Yeah, horizontal also. But for this, the oscillation is perpendicular to the energy transmission because it is vertical. The oscillation of medium. Betul tak? Kalau spring, ini adalah spring lah, ya. Kalau one type of let's say this is a spring. Even the sound wave also, sound wave through the air particle also a longitudinal wave. Yeah, the oscillation is parallel to the energy transmission because both are horizontal. Okay, but for transverse wave, the oscillation of medium is vertical, energy is horizontal, so they are perpendicular. Okay, so example for transverse wave is like string. This one is spring. This one is spring. This one is spring. This one is string. Or you can also use water. Yeah, water wave also a transverse wave. Water wave. Okay. Understand, class? Water wave. Okay,
Yes,
so done. So mechanical and electromagnetic wave. So this is actually I'm describing the concept first before we go to the equations. So am I recording? Yeah. Okay, so you see the particles oscillate around the equilibrium position but do not travel. Oscillate but do not travel. You understand what it means? It oscillate about their equilibrium position but do not travel. You look back at our animation. It oscillate yet do not travel. It oscillate yet not travel. You know what I mean? A continuous and repetitive disturbance give rise to continuous propagation of energy that we call a wave motion. Yeah, the disturbance is continuously oscillating. So as time goes by, the energy is transferred out. Yeah, all the neighboring particles are being disturbed. It's like, how is it being disturbed? You see, let's say this is a disturbance. This is the disturbance. When it starts to oscillate, then the next particle, wait, what is this? Then the next particle here will also start to oscillate. Okay, and then who will join? The second particle will start to oscillate also, right or not? And then who will join some more? The third particle will also start to oscillate. So as soon all the particles here will also continue to oscillate because of neighboring particles, you know, one by one. The disturbance disturb the first particle disturb the second particle disturb the third particle, and the process move on. So if this disturbance continuously oscillate, so as time goes by, all the particles along will start to disturb also. And you can see this dark. You see this dark? What does it tells you? What does it tells you?
It's not moving.
It's not what? It's going? It is not moving. You say not moving. Not moving means not travel with the wave. Energy is going from left to right already. Energy has reached the right hand side. But the dark doesn't go to the right hand side. It just go up and down. Can you see that? So we can actually just treat this dark as just one particle. It just go up and down. That's it. It remain. The motion of the dark is always up and down, and it doesn't go to along with the energy. So all the water particle also the same. They also oscillate up and down. But the first particle here doesn't go to here. So I can say, let's say I throw a rubbish over here. And if the wave is just a normal wave, you jangan harap rubbish itu akan pergi ke pantai. Rubbish itu akan stay di situ lama-lama. Faham tak? Tapi kecuali ada ombak yang tolak lah. Maksud kalau ombak itu dia macam mana? Dia akan ambil masa yang sangat lama lah ya, ataupun ombak itu bukan dalam gelombang yang biasa, tapi dia macam ada yeah. So it takes a very long time kalau pun nak sampai itu pergi ke pantai lah ya, maksud saya ya. So sebab kenapa? Sebab dia oscillate up and down saja. Oscillate up and down ya. Tapi kalau yang tengok di sini ombak ini dia you know okay. Okay. So susah nak explain saya. So yeah, by the way, I can say that sampah normally, theoretically, is just going up and down. Yeah. Okay, so sama macam ini. I see that this particle, I see the red particle just remain at the same position. It doesn't go to the right. Yeah, it doesn't go to the right. Okay, and then the wavelength means from crest to another crest. It's called a wavelength. Yeah, from crest to another crest is called a wavelength. Even the trough to another trough, also a wavelength. Trough to another trough, also a wavelength. Okay, all right. And then, what is wavelength? Wavelength is defined as distance between crests, or distance between trough. Yeah, from crest to crest or trough to trough is one wavelength. Yeah, I see this one. From here to here is called one wavelength. From trough to trough also one wavelength. You know, from trough to trough maksudnya dari sini ke sini lah. Dari sini ke sini pun dikira satu wavelength. Even dari tadi dari sini ke sini, dari crest to crest, and then also from here to here also another wavelength. Okay, or you can say from here to here also. See that? From here to here. Also another wavelength. Okay? But from here... Okay, what about from here to here, class? What about from here to here? From here to here, what is this? Half wavelength lah, okay? Setengah wavelength, betul tak? Setengah wavelength, ya? Tapi kalau from, let's say from here to here macam mana? Dari sini ke sini macam mana? Berapa panjang dia? Lambda over 4 lah. Betul tak? So itulah. Saya nak you tengok dulu sebab nanti akan keluar benda ini juga. Okay, from here to here is lambda over 4. Okay, very good, very good. Let's say from so okay, saya nak tanya kamu dari sini, saya terus uji kamu ya. Dari sini ke sini berapa wavelength ini? I suka. You kira berapa? Dari sini ke sini berapa? 1, 2, 2 and a? Huh?
1/2.
1, 2, 2.5. Betul tak?
Yeah.
So the whole thing is 2.5 wavelength. Bukan 1/2, is 2/1/2. Okay? Okay, 2.5 wavelength. Good. So it's distance for one complete wave cycle. So the wavelength lambda. Pernah tengok simbol ini lambda?
Benar.
It's called wavelength. Okay. You need the meter. And then we have one equation k equal to 2 pi over lambda. Is called wave number. Yeah, number of waves per unit distance. Yeah, number of waves per unit distance. Wave number. It's just a ratio. Just a ratio. Yeah, number of cycles per unit distance. Later I will explain to you. So just a ratio. You know, it's like kalau tengok dari sini kan, dari sini ke sini, ini kan 2 pi, betul tak? Dari sini ke sini ialah 180 darjah, betul?
Betul.
Dari sini ke sini ialah 2 pi, 360 darjah, betul tak? 2 pi. So kita boleh anggap 2 pi ini bersama dengan 1 lambda, betul?
Betul.
So boleh kata 2 pi bahagi lambda adalah macam satu ratio, betul tak? Macam satu ratio, ya. Yeah? So it's just a ratio lah, ya. Yeah? Kenapa perlu bahagi? Kenapa perlu buat begini? Nanti saya akan explain, ya. Yeah? So this is a wave number. It's just like a ratio because 2 pi is like 1 lambda. So we divide 2 pi with over lambda, then we get one ratio. Macam kita nak convert, let's say, let me give you one example. I like to give example, yeah, so that you understand. Walaupun sebenarnya apa yang saya explain di sini actually panjang lebar, ya, tapi you know I want to give meaning. You dah belajar macam mana convert radian ke degree to radian kan, betul tak kelas? Apa you buat, ya? 30 darjah berapa radian? Macam mana convert?
Darah pi per 140.
So but before that, what do we do? Kita tengok dulu. Ini 360 darjah bersamaan dengan berapa? 2 pi radian, betul tak?
Yeah.
What's the time now? Okay, almost time. But okay, but we are going to finish. Yeah, we're going to finish because I'm excited. You know, that's why I'm always excited at things. Right? This is my characteristic lah. Yeah, yeah. If I'm not excited, I cannot proceed with my life. Yeah, better end my life. Okay, so 360 degree. So we make a ratio, right? 360 over 2 pi kan? Betul tak? Is equal to 1, right? It's like a ratio, betul tak?
Yes.
So this is very important. This ratio is very important because it helps us to convert unit. Or we can also make it like 2 pi over 360. It's like equal to 1, correct or not? Okay, so now with this value, we can convert degree to radian, correct or not? So the 30 degree multiplied by what? 2 pi over 360. So what do you get? class? What do you get? Correct or not? Correct me if I'm wrong. So it's pi over 6, betul tak? Radian. We got it. We got in radian. 30 degree is pi over 6 radian, betul tak? Good. This is important, This is important, Don't look down on this, because this is what it means by this equation. This equation. The meaning of especially this part. Especially this part. These two things, they are ratio. To convert it, to convert something from time, from time to radian. Convert from distance to radian. Understand? Convert from time to radian, convert from distance to radian. That's what I mean by ratio. That's the meaning of omega here. Omega is a ratio. Wave number is also a ratio. It's just to convert whatever time to radian, because sine, because we're talking about sine theta kan, betul tak? Dan ini kita guna radian, kita guna unit radian. Kita bukan guna degree lah, kita guna radian. That's why kita perlu guna apa? Perlu guna apa? I always choose the wrong thing. Perlu guna 2 pi. I choose the wrong thing again. Never mind lah. Understand? So it's to convert everything from time to radian, distance to radian. Because we are using unit radian over here. Okay? So this equation I will explain more later on. I think time's up until now lah. Okay, time's up until now. So I will continue with this explanation some other time. Okay, class? You understand?
Okay, sir.
Understand the lesson?
Yes.
Yeah.
Yeah. So what I'm trying to explain over here about this ratio, you go back and think for a while. Betul ke apa yang saya cerita? Apa yang saya cerita make sense tak? Satu lambda memang around 2 pi lah. 2 pi radian. So, satu lambda macam satu period. Also about 2 pi radian. So, I make a ratio over here. So, 2 pi over lambda is equal to 1. This one, 2 pi over period. So, when I want to change something, like you see, when I want to change something, when I want to change something from degree to radian, I put the radian at the top. I put the 2 pi at the top. Betul tak? I letak 2 pi di atas kan? Betul tak? Sebab saya nak tukar dari degree pergi radian. 2 pi saya letak di atas. So, sama macam benda ini. Ini pun 2 pi saya letak di atas. So, yang ini wavelength di bawah. So, nanti darab sahaja dengan apa? Darab dengan distance itu. Maka ini darab dengan time itu. Maka this whole thing we will get how many radian. How many radian. Dan boleh masuk dalam formula sine ini. Itu maksud wave number dan angular frequency. Okay, tak apa. Ini saya akan explain lagi some other time. Okay, thank you for your time and see you again some other time. Bye.
Thank you, sir.
Thank you, sir.
Okay.